Okay, so we're stuck on trying to. You found this power was 3 mod 4. You found this power was 3 mod 4. You found this power was 3 mod 4. And we're trying to do a general thing, but what I'm telling you is you can't bring the mods up into the power. The mods only stay down at the very bottom. But there is an argument that you can make that why this power tower is 3 mod 4.
Well, powers of 3. So if you're at the top of the power tower, you can evaluate. You can start evaluating it down, and you're gonna get some. Eventually, you're gonna get some giant power. You're gonna get 3 to some giant number.
Right, you're gonna get 3 to some giant number.
But that giant number is gonna be. That giant number is gonna be some amount of 3's multiplied together.
That's right. That giant number, the only thing you can say about that giant number is it's some number of 3's multiplied together.
Well, what... We know that... Because we can multiply 3's and not get... We can multiply 3's and not get 7's. Because we don't need... All multiplications of 3's will not result in 7.
That's right. Not all multiplications of 3 result in a 7. But we seem to always be getting 7, at least in these 3 cases. So in the 3 to the 3 we got the power was 3 mod 4, that was easy to see. 3 to the 27th was 3 mod 4, that was easy to see. 3 to the 27th, why was that 3 mod 4?
3 to the 27?
Yeah, why was 3... How did you figure out here that 3 to the 27th was 3 mod 4?
So we figured out that 3 to the 27 was 3 mod 4.
Yes, then that was my question. How did you figure that out?
So we looked. So we looked. We said 3 to the 27 is going to be. It's just going to be a lot of 3's multiplied together.
Okay.
And then we grouped those 3's in groups of 2 to make 9's, which were 1 mod 4. So all but one of the 3's just turned into 1's.
Okay.
So 3 to the 27 is just like 3. In the sense.
Okay.
So I guess what you could do is you can evaluate the top part till you get a 3 to the 27. Replace the 3 to the 27 with a 3.
You can't bring the mods up into the powers.
But isn't that what we were doing here?
Not really. What did you do here for 3 to the 27th? Why don't you write it out?
So for 3 to the 27, we said this was 3 times 3 times 3 times 3. 27 3's. Then we grouped the 3's in groups of 2 and left this one.
Okay.
Then these groups of 3, mod 4, were all 1, except for this one here.
Right.
That turned into 1 times 1 times 1 times... So 14 1's times 3.
Okay. So here you were looking at what is this whole expression, 3 to the 27th mod 4. You know mod 4, if this number 3 to the 27th is 1 mod 4, you know the last digit's 3. If it's 2 mod 4, the last digit's 9. If it's 3 mod 4, the last digit's 7. If it's 1 mod 4, the last digit is... Sorry, if it's 4 mod 4, the last digit's 1. You found that 3 to the 27th, through this argument, was equal to 3 mod 4.
Yes.
And so this ended in 7. And so we're going to try to extend this argument now to 3 to the 3 to the 3, but really far up, to Graham's number.
Yes, but didn't I put the mods up in the power when I did this? And so 3 to the 27 is equal to this. And I took all of these mod 4. Wasn't that putting the mods in the tower?
It was you were evaluating this number, the power. You were evaluating the power, but what you're trying to do now is bring them up into a power up here.
Okay. And so I can bring it up into the... I can bring it up into the entire power.
Right, into the entire power. But you can't bring it up into a part high up in the tower.
So essentially what we have to do is... I guess... I guess we can be sure that this is going to happen for our giant power of 3's because we know that whatever big number that we get at the end is going to be odd.
Okay, how do you know that?
Because we're multiplying 3's together.
Okay.
We're multiplying odd numbers together, so we'll get odd numbers out.
Mm-hmm.
So we're going to get a giant string of 3's, but it'll be an odd number of 3's. So we can group them just like we did here. And then we will be left with 1 3 left over.
Okay.
And that will make it 7.
Yeah, so the amazing thing is that the argument's actually for 3 to the 27th and for 3 to the 3 to the 3 to the 3 to the 3 all the way up to Graham's number, for the last digits, the argument's exactly the same. You can group the 3's like you did and find that that power tower is 3 mod 4. That's pretty cool.
Mm-hmm.
All right, so good. Let's talk and see if we can find the last 2 digits, but this time we'll do it using a computer.
All right.